All right, guys. Any questions on any of the homework assignments thus far? Any questions on any of the homework assignments thus far? No. Also be helpful if I have the graphing calculator application pulled up. Yep. And quit. Over here. So what we talked about on Friday is solving these polynomial equations, these higher degree polynomial functions. And when we looked at a lot of them, the first thing we really looked at was graphing it, because the more zeros we can find, the better. And for any of them, if I can bring it down to a quadratic, I can solve it from there using the quadratic formula. And really that's the goal with graphing, is to get it as low as we possibly can and then go from there. So we'll look at one of these two here. Which one of these two do y'all want to look at? Number 3. So when we look at this here, 3x to the fourth minus 6x squared plus 3. We want to find the solutions. And how many do we want to find by graphing at least? 2. Because if I can find 2, we can use synthetic division to bring it from a degree 4 to a degree 3 and from a degree 3 to a degree 2. And then we can go from there using our properties for quadratics. So the first thing we want to do is just to type it into the graphing calculator. So we can pull the graphing calculator up. We can hit y equals, and we want to type this equation into the first spot. 3x to the fourth minus 6x squared plus 3. So we want to get it typed in first. And after we get it typed in, what do we hit? Graph. And we do see 2 points where it hits the x-axis, or it just barely crosses it, or it's just touching that spot. Now, if it's just touching the x-axis at these 2 points, how many zeros will we have there? 2. We're going to have an even number. So here, it most likely we'll have 2. To get a better look at it, we can go second graph and look at the table. And it's telling us that the solutions are at -1 and 1. These two would be our solutions. Any questions on how we found this here? So x is equal to 1, -1, and most likely we're going to have 1 and -1 again. We'll have it twice because we're looking for 4 solutions. Now we can go on and check this with synthetic division. Inside the cubbyhole we can pick 1. It really doesn't matter which one we do first. Across the top we would have 3 for x to the fourth, and then 0 for x cubed, -6 for x squared, 0 for x, and then 3. And then we would bring down the 3. 1 times 3 is 3. Add straight down, 0 plus 3 is 3. 1 times 3 is 3. -6 plus 3 is -3. 1 times -3 is -3. 0 plus -3 is -3. 1 times -3 is -3. And last but not least, 3 plus -3 is 0. And the last 0 would be our remainder. Did we expect the last number to be 0? Well, yes, because we know it's a solution, so the remainder has to be 0. What number do we want to try next? Doesn't matter. Which one do you want? we can do -1, bring down the 3, and do this again. -1 times 3 is -3. 3 plus -3 is 0. -1 times 0 is 0. -3 plus 0 is -3. -1 times -3 is +3. And -3 plus 3 is 0, which is the remainder that we thought we should get, and we know we would get. All right. Do we want to try another number, or do we want to just solve? So we can plug the variables back in. So this is our remainder. Our -3 would be our constant. 0 would be the term with x, and 3 would be the term with x squared. So what we're left with is 3x squared minus 3 is equal to 0. Get a little more room. What can we do first? Well, we don't have a middle term, do we? Because we could factor, or since there's not a middle term, we can actually use the square root method. Get the x by itself, because that's a little bit easier. So we could add 3 to both sides. And if we do that, -3 plus 3 is 0, leaving us with 3x squared is equal to 3. And then what can we do? Divide by 3, which tells us that x squared is equal to 1. And last but not least, we would square root both sides, telling us that x is equal to plus or minus 1. And really, we also have that x is equal to plus or minus 1. Any questions on this here? Any questions on any of this here so far? All right. The rational root theorem. The rational root theorem. This here will give us all the possible rational roots that we could possibly have for any higher degree polynomial function. Now, the way that we get to these rational roots is kind of following this here. If f of x is equal to, again, as I said last week or said the other day, this here is just defining any and all polynomial functions that we could possibly have. Has integer coefficients, then every rational solution of f of x equals 0, every rational solution that we could have. So rational, we're talking about any number that can be written as a fraction. So irrational numbers, so anything that deals with a radical that can't be reduced down won't be included in this. Or complex solutions, solutions dealing with I, they won't be included. But we can get all the others. Are going to come in the following form here, P over Q. P is the constant factors, or the factors of the constant term, divided by the factors of the leading coefficient. P over Q. So the rational root theorem is that we're going to take the factors of the constant term and divide it by the factors of the leading coefficient. This will make a little more sense when we actually look at it. Find all the real solutions for this here. So we're going to find all the rational roots, and then we'll go about actually finding what the actual solutions are. So P is going to be all the factors of the constant term. So what is our constant term? 20. So what are our factors of 20? Well, 1 and 20. What else do we have? 210. Do we have any others? No. All right. What are our factors of the leading coefficient? Anything else? No, because what is the leading coefficient? 1. Okay. Any questions on how we found P and Q? Now, the way that I find the rational zeros, all the possible rational zeros, we're going to put plus and minus because we'll deal with the positive and negative case of these here because they could be positive, they could be negative. I'm going to start with Q, whatever the first factor of Q is. So here it's just 1, yes? And we're dividing all the factors of Q by all the sorry, I got that backwards. We're taking all the factors of P, the constant term, and dividing it by all the factors of Q, the factors of the leading coefficient. And I start off with just 1, and we're going to divide them all by 1. So our first one would be 1 divided by 1, which is just 1, yes? Then we'll do 2 divided by 1, which is 2. 4 divided by 1 is plus or minus 4. 5 divided by 1 would be plus or minus 5. 10 divided by 1 would be plus or minus 10. And 20 divided by 1 is plus or minus 20. So have we done all the factors of P over our first Q term? Yes? Then if we had another, well, the only Q term we have is 1, yes? We're done. If there had been another one, we'd move it to whatever the next factor of Q is and do the exact same thing. We'll see one of those in a minute. Now, how many solutions will this have? 3. The degree is 3, so it's going to have 3 solutions. How many possible zeros did we just list out? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So will all of these be solutions? No. Well, the rational root theorem, then every rational solution of this has the following term. So is it talking about all the solutions? No, then every rational solution will form this here. Every rational solution that it has, every possible rational solution is what this gives us. So if it does have rational solutions, this formula here will give it to us. Okay? Any questions on this here so far? Okay. I'm just moving this up just a little bit so I have more room. I'm just going to move it in parts. Really move it in parts. Okay, at least that's all 1. There we go. Now, if we went by the pure mathematical way to do this, I'd set up synthetic division. 1 would be for x cubed, negative 8 for x squared, 11 for x, and then 20. X cubed, x squared, x, and 20. Guess what we would do? I'm going to start out at grab blue 1 to see if this works. Because if it gives us 0, then that's a solution. If it doesn't, then it's not a solution. Well, let's check and see if 1 is a solution. Well, 1 times 1 is 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. 11 plus negative 7 is 4. 1 times 4 is 4. 20 plus 4 is 24. That's our remainder. So is 1 a solution? No. Okay, well. Take my eraser, erase all of that. Erase all of that. All right, well, 1 didn't work. But you know what might work? -1. And we'll do it again. -1 times 1 is -1. -8 plus -1 is -9. -1 times -9 is 9. 11 plus 9 is 20. -1 times 20 is -20. And 20 plus -20 is 0. So one of the solutions is -1. Now we could try -1 again because, as we've seen before, can we have a solution repeat? Yes. But what degree are we at now? 2, yes. So we could also switch over to quadratic formula because we can put back in our x and x squared and see if we can solve it from here. So we could solve it by factoring. We could see if it would graph. And we could also use the quadratic formula. We can just stick it in the quadratic formula. To get our answer. I'm going to extend the page just a little bit. Probably won't need that much. So the number in front of x squared is our a, the number in front of x is b, and the constant term is c. So here the value of b is -9. So our negative b, -9, is just going to be +9. Inside the radical, we'd put parentheses -9 squared minus 4. A is 1, and C is 20, all over 2 times 1, which is 2. Now at this point here, we could plug everything that's inside the radical into the calculator first, just to make sure that this works out to be a whole number. And if we're using the TI-30XS, it doesn't work out to be a negative. Well, -9 squared is 81. 4 times 1 times 20 is 80, and 80 minus 81 is 1. Well, hopefully, square root of 1 is 1, because 1 times itself is 1. Luckily enough, any root of 1 will always work out to be 1. Now that we can do 9 plus 1 and we can do 9 minus 1, yes? We can add and subtract those, so we'll need to. Well, here 9 plus 1 is 10, and 10 divided by 2 is 5. Here 9 minus 1 is, and 8 divided by 2 is 4. So our solutions for this here was x is equal to -1, 4, and 5. Were all 3 of these numbers listed in our possible rational zeros? Yes. Could we have actually graphed this and got all 3? Well, yeah, because they're all whole numbers, it would have told us these. But that's it. Questions on this here? Thank you. I'm going to skip ahead to this because as I was looking at the other few, I don't find them really interesting. This one here I do. Let's find our possible rational zeros first, and then we'll find the solutions. So if we look at this here, we're looking for the factors for p, the factors of the constant term. So we're looking at 12. So we have 1 and 12, 2 and so those are all the factors of 12, yes? Now the factors of q, the leading coefficient, well, we will have 1, but we will also have, what else? 10, and then 2 and 5. This is why I said this one's a little more interesting than the last few, because if you look back at the last few, the leading coefficient for all of those is 1. It really doesn't do much. Any questions on how we found the factors of p and the factors of q? Our possible rational zeros is going to be p over q, and we'll have plus or minus in front of all of them. Now, personally, I start out with 1, where q is 1, and we're just going to divide each thing by 1. Well, anything divided by 1 is just whatever we have. So we'll have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So we're really just going to relist all the factors of p with a plus or minus. Now, if a factor is repeated, we don't write it twice. If a factor shows up more than once, or a possible rational zero shows up more than once, we don't write it twice, or 3 times, or 4 times, or however many times it shows up. Because as long as it's in the list once, we're good. And you'll see why here in a second. Now the next number we're going to choose is 2. So the next one we're going to have is plus or minus what? 1 divided by 2, which would be 1/2. What's going to be our next one? 2 divided by 2, yes? What is 2 divided by 2? Do we have that? We don't list it again. If we have it, we're going to write it again. Our next one would be plus or minus 3 over 2, because that really doesn't reduce down any farther than that. 3/2 is still 3/2, yes? Let's move on to the next one, which would be 4 divided by 2 is 2. Do we have it? Okay, we move on to the next one. 6 divided by 2 is 3. We have it. 12 divided by 2 is? We have it, yes? Okay, we're done with 2. So we can move on to 5. Most likely, we're going to have plus or minus 1/5. Whatever number, because we're always going to start with 1, that one's always going to show up, because that really doesn't reduce any further down. Now we can look at the next one. Well, 2 divided by 5 is 2/5. Then we do the next one, which is 3 plus or minus 3/5 plus or minus 4/5 plus or minus 6/5 plus or minus 12/5. Well, one, 2, 3, 4, 6, and 12. None of them have a common factor with 5, so we're going to end up writing them all. Any questions on this here before we move on to 10? 10 is last. Well, we're definitely going to have 1/10. So the next one would be what? 2 divided by 10, yes? All right, up here just so we can see it. Is there a common factor between 2 and 10? Well, 2, and it would reduce to what? We have that, yes? So I don't need it again. Then we can move to 3. Well, we'll need 3/10 because 3 and 10 don't have any common factors, so we'll have it. What's the next one going to be? 4 divided by 10. Does it reduce? 2/5. Okay, we have that. 6/10 would reduce to, and 12/10 reduce to 6/5. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 32 possible rational zeros because we have 13 and there's 2 of each. What is the degree of this polynomial function? So how many actual solutions do we have? So only 4 out of those 32 are actually going to work. What would y'all want to do next in solving this? I agree. I would type this in a calculator. Because it could be that we, on the first try of 1, that we could get the correct answer, but we could also not. So we can do 10x to the 4th minus 11x to the 3rd minus 42x squared plus 7x plus 12. Okay. 10x to the 4th minus 11x squared minus 40, or 11x cubed minus 42x squared plus 7x plus 12. And then we hit graph, yes? So how many zeros do we have? 4, because we see it cross 4 times, yes? And they cross in nice whole numbers. Well, let's look at the table real quick and see. I don't see any zeros here, do you? No, and if we look back at the graph, well, -4, it is between -2 and 3 for the x values, yes? Now let's see where we have. Well, we have one that's very close to 3. It's between 2 and 3, yes? So we have between 2 and 3, kind of closer to 3. We also have between 0 and 1, and it's kind of closer to 1, yes? We also have between -1 and 0. Do y'all think it's close to either one? No, it kind of looks right there in the dead center, yes? And the last one is between -1 and 2. -2 and -1. And it's leaning a little bit closer to -2, it looks like, yes? But it didn't give us any rational zeros. It didn't give us any whole numbers, correct? Okay. Any questions on this here before we go back to the other slide? You're welcome. So this here is all the possible rational zeros that we can have, yes? Which ones do we know won't work? The whole numbers. All of these here are gone. Well, how many did we just eliminate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we're left with 20 that could work, yes? So we're going to use synthetic division. So the numbers going across the top are going to be 10 negative 11, negative 42, 7 and 12, and we're going to bring down the 10. Now we're going to use the locations of where it crosses the graph, because it gave us fractions, yes? And one of them stands out to me in particular. That's the one between 2 and 3, yes? So we're looking for a number that's actually greater than 2. How many possible zeros up there are greater than 2? So 1/2, is that greater than 2? How about 3/2? 1/5? 2/5? No. 3/5? No. 4/5? Because that's all less than 1. 5 or 6/5? No, it's greater than 1. 12/5? Yes. And is it going to be positive or negative? Positive, yes? Wait a minute. Did we do any calculations yet? No, because we looked at the graph and we saw where they crossed the graph, yes? And the one that lined up best, if it is a rational zero, is possibly 12/5, and we'll check to see if that is the correct answer. So well, the first thing we can do is 12/5 times 10. And we can type this in a calculator, or 10 divided by 5 is 12 times 2 is 24. And that might be the nicest number for the rest of this here. Negative 11 plus 24 is 13. 13 times 5/12, or 12/5. 13 times 12 is 144. And then we have to add to it negative 42. Which is going to be I'm going to need a calculator at this point. Negative 54 over 5, and then we'll multiply it by 12/5, which will be negative 648 over 25. Add 7 to it, negative 473 over 25 times 5/12. Negative 473 over 60 plus 12, 247 over says 5/12 the solution. Now, what does that tell us most likely? That row's no good, but also that intersection of the graph isn't going to be a rational number. Well, no, because this here, the P over Q, gives us all the possible rational zeros. Is there any other possible rational zero that we have listed up here that's greater than 2? Well, no, the only ones after that are 1/10 and 3/10. Neither one of those are going to be it. Okay. Now we did have that between -1 and 0, it did work out to be kind of partway in the middle. Let's try -1/2. And we can take out the positive and really negative case of 5/12. Because it's not going to work. So let's try it with -1/2. -1/2 times 10, or 10 divided by 2 is negative 5. Looking a little promising. Negative 11 plus negative 5 is negative 16. Negative 1/2 times negative 16, well, the negative and negative would make 8. 16 divided by 2 is 8. Negative 42 plus 8 is negative 34. Because, because 42, negative 42 plus 8, 2 would get us down to 40, which would leave us with 6, which would get us down to 34. Negative 34 times negative 1/2, well, the negative and negative again, positive 34 divided by 2 would be 17. 17 plus 7 is 4. Our new number would be negative, and half of 24 is negative 12 plus 12 is we have found one solution, yes? How many more do I need, at least? Because we need at least one more. Because we have a total of 4. We found 1, which brings us down to a degree 3. We need to get down to a degree 2. Okay. So negative 1 and 0 we found. Now we said that this is probably irrational or not real. So the one that's closer to 3, between 2 and 3, is probably going to be irrational or not, well, just irrational, because it can't be not real because it did cross the graph. Now, will negative 1/2 work again? No, because it definitely did cross, and we do have a total of 4, so it's only going to work once. Now, our only other option is between negative 2 and negative 1, which most likely is not going to work, because any irrational square roots always come in pairs. Kind of like our complex conjugate, where we had the plus and minus I. They're going to come in pairs, so most likely that's going to be its pair. So we're looking between 0 and 1, positive, and it's closer to 1. Four-fifths? Okay. So the first thing we're going to do is drop the 10 and then multiply it by 4/5 times 10. Well, the 10 and 5 would give us 2, and 4 times 2 is 8. Negative 16 plus 8 is negative 8. 4/5 times negative 8 is going to be negative 32/5. Is this going to look any better as we get further along? No. Okay. So probably not 4/5. Three-fifths? Sure, let's try it. Well, help if I have a pen. 3/5. And a lot of this multiplication I'd be doing in a calculator, especially when we're dealing with fractions. 3/5 times 10. Well, again, the 5 and 10 would reduce to 2. 3 times 2 is, add straight down, negative 16 plus 6 is negative 10. 3/5 times negative 10 would be, add straight down, negative 34 minus 6 is negative 40. 3/5 times negative 40. What are we hoping this gives us? negative 24. Well, negative 40 divided by 5 is going to give us negative 8. 3 times negative 8 is negative, which gives us as our remainder, yes? Okay, we found another one. How many more do we need? Now this here, so x squared x, so we have 10x squared minus 10x minus 40 is equal to 0. Is there a greatest common factor between these three numbers? What is it? 10. You know what? Divide everything by that number. Because what that, if we do it now, it's going to save us on the back end. Because when we plug this into the quadratic equation, quadratic formula, there's going to be a greatest common factor of 10 on top and bottom. Yes?
So if there, not only is there greatest common factor of 10, but it's also 5. No, you said 10. Oh, 10. Okay.
Yes. You're good? Well, that's just going to be x. Because taking it out now makes the quadratic formula work a little bit better. Because if we leave it in there, there will be a greatest common factor of 10 that has to be reduced after we finish in part of the quadratic equation or quadratic formula. Now, do we think this will reduce to whole number answers? Well, no, because it would have listed them if it did, yes? So most likely it's not. X is equal to, well, negative b, our b value is negative 1. So it would just be 1, because negative 1 would make it positive 1. Plus or minus the square root of negative 1 squared minus 4 times 1 times negative 4 all over 2. Just hang in there with me. We'll finish this up and be done for today. 1 plus or minus. Here we'll end up getting 17 all over 2. Because 1 squared is going to be 1. That's going to be positive. And that's actually our other two answers. The square root of 17 won't reduce, so that's it. So we'd have that, negative 1/2, and 3/5 as the solutions. We will finish